Hello, and these are the notes for Unit 6, Day 3, Solving Systems by Substitution. So we're going to solve a system of equations by substitution. Substitution method. To solve a system of equations by substitution, a variable can be replaced with an equivalent expression. So what I'm going to do is if I have 2x plus 3y equals 9 and x equals y minus 3, I'm going to circle that y minus 3 and substitute it in for the x here. So I'm going to get 2 times y minus 3 plus 3y equals 9. So I'm replacing what's in for the x for y minus 3. Then you distribute. So we get 2y minus 6 plus 3y equals 9. Combine like terms that are on the same side, because the y's are on the same side, so combine like terms. So 2y and 3y will give me a 5y minus 6 equals 9. Add 6 to both sides. So 5y equals 15. Divide by 5, so y equals 3. So I'm dividing by 5 here. All right, we got y equals 3. And we know that x equals y minus 3. So x will be 3 minus 3, or x equals 0. So my solution is 0, 3. So then check that, just kind of look at it and make sure. So 2 times 0 plus 3 times 3, does that equal 9? That's 0, so 9 equals 9, yep. And then the last one, does x equal y minus 3? And so does 0 equal 3 minus 3? The answer is yes. So this is okay. So what you're going to do is isolate a variable from one equation, substitute into the other equation, that is critical here, other equation, solve for the remaining variable, back substitute, and solve for the other variable, write the answer as a point, meaning x comma y. All right, solve this system by substitution. We start with one that's already crazy hard. We got this though. All right, so what I want to do is look at those equations and see which one would be easiest to find y. Looks like y in the second one, or to find x. So this one is nice. So we're going to solve for y here. So if I solve for y, I'm going to move the 3x over. So if it's positive 3x, when I move it over, it becomes a negative 3x. So I have negative y equals 19 minus 3x. And I need y by itself, so I'm going to divide everything by negative 1. So y will be negative 19 plus 3x. All right, so then I circle this. This is my y, and I'm going to substitute it in for the y in the other equation. So go to the other equation, which gives me 2x plus 5 times negative 19 plus 3x equals negative 10. You will have to distribute the negative 5 through here. So leave the 2x out front. So 2x, so 5 times negative 19. Need a calculator. 5 times negative 19 is negative 95. And then 5 times 3x gives you plus 15x equals negative 10. You then combine like terms, so 2x and 15x on this side, so which that gives me a 17x minus 95 equals negative 10. Add 95 to both sides. So 17x, let's go away, equals 85. Divide by 17. X equals, so 85 divided by 17 is 5. I'm going to circle that just so I keep track of that. And I know y is negative 19 plus 3x, so negative 19 plus 3 times 5. All right, we're going to wrap up these notes. So I'm substituting in that 5 for the x. Put that 5 there. Let me get a pencil instead of, let's get this to work. So 3 times a 5 here. So y will be negative 19 plus 15. So y equals negative 4. So my answer is 5 comma negative 4. So let's do a check of that. So I'm going to 2 times 5. This is a check. So 2 times 5 plus 5 times negative 4, does that equal negative 10? So that's 10 plus negative 20 equal negative 10. The answer is yes. And then the other equation, 3 times 5 minus a negative 4, does that equal 19? So 15 plus 4 equals 19. The answer is yep. This is our answer. All right, the next one, solve by substitution. I'm looking at that first equation here, and I see if I solve for x, it will be fairly easy. So I'm going to move this 4y over because the x has a coefficient of 1. So I'm going to say x equals then 6 minus 4y. I'm going to circle that and substitute in the other equation. So twice of 6 minus 4y minus 7y equals negative 3. Distribute, so we get 12 minus 8y minus 7y equals negative 3. These two are on the same side, combine like terms. So 12 minus 15y equals negative 3. So subtract 12, subtract 12. So negative 15y equals negative 15. Divide, divide, so y is 1. I substitute that back into what I saw for x. So I say x equals 6 minus 4 times 1. So x will be 6 minus 4, which means x is 2. My solution, right, is at coordinate points 2, 1, which means that's where those two lines meet. So let's do a check on this. X is 2. So let's do a new color here. So check here. It's first equation, so I'm going to put 2 plus 4 times 1. Does that equal 6? 2 plus 4 equals 6. The answer is yes. And then the next one, twice of 2 minus 7 times 1. Does that equal negative 3? So 4 minus 7 equal negative 3. The answer is yes. There's a solution. This one, solve the system by substitution. I'm looking at this, and I see that has a coefficient of 1, so that will be the easiest to deal with. So I'm going to move this 2 over here. So I can say then that y equals 3x minus 2, because I'm going to minus the 2 on the left side. Circle this, substitute in for that y. So I have negative 2x minus this new y, which is 3x minus 2, equals negative 8. This is actually a negative 1, think of it as. So I'm going to distribute a negative 1 through there. So negative 2x, negative 3x, plus 2 equals negative 8. Combine like terms again. So negative 5x plus 2 equals negative 8. Subtract 2 on both sides. So negative 5x equals negative 10. Divide by negative 5. So x equals 2. Circle that, and we're going to substitute it back where I saw for y. So I can say y equals 3 times 2 minus 2. So y will be 6 minus 2, or 4. So my solution, write it as an x comma y, so 2 comma 4. Write it as a coordinate point. Again, I like to do a check on these, so let's check. So the first equation would be negative 2 times 2 minus 4. Does that equal negative 8? Negative 4 minus 4 equals negative 8. Yep. And then the last one, does 3 times 2 equal y plus 2? So that's 6 equals 6. The answer is yep. My answer is there. All right, sometimes you might have infinite many solutions or no solution. Always false means a no solution. Always true means infinite many solutions. All right, which means up here this is a parallel line situation. And this means it's the same line. twice. All right, looking at this equation here, I can see x is, if I move this 2y over, that will be easy. So I can say x equals -3 plus 2y. All right, and I'm going to circle this and substitute in for that x. Get a new color here. So I have 6 times y. Thought I clicked a new color, but it's not. So 6 times y minus 9 equals 3 times my new x, which is that. And then I get 6y minus 9 equals, distribute this, -9 plus 6y. Notice I have this and this, which are they're the same thing on both sides. Or let's say, I don't quite notice that yet, and you just you keep working and you put minus 6y on both sides. That's okay too, because then what am I left with? -9 equals -9, which is always true. So my answer is infinite many solutions. That's how I want you to write it. It means it's the same line twice. All right, solve by substitution again. I'm going to take this equation and solve for y. We could solve for 2y, but let's just solve for y. So I can say 2y equals 4 plus 8x. So if it's a -8x here, when I move it over, it becomes positive 8x. So I'm adding 8x to both sides. Divide everything by 2. So y will be 2 plus 4x. Circle this, substitute this in for that y. So I get 8x minus 2 times my new y, 2 plus 4x, equals 7. Distribute that -2 through there, but leave 8x here. Minus 4 minus 8x equals 7. Combine like terms. So you see 8x, -8x, they're gone. So I get -4 equals 7. That is not true. That is sad face. So this answer is no solution. You have parallel lines. And here's the assignment. And when it says, notice this, solve all problems from 5.4 by substitution. So ignore the directions, solve by substitution.